All right, so every time we open our news feeds lately, right, we are just bombarded with images of extreme weather. Catastrophic floods, prolonged droughts, massive wildfires. Honestly, it can feel like the entire planet is constantly on edge. In this explainer, we're going to strip away all that noise. We're looking strictly at the science to understand what is actually happening to our world and why these extreme events seem to be literally everywhere. Which naturally brings us to the central question on absolutely everyone's mind. Are natural disasters actually getting worse? I mean, are we just paying more attention because of the 24/7 news cycle and social media? Or is there a genuine physical shift happening out there? Is this surge in catastrophic floods, wildfires, and hurricanes a real, measurable trend? Well, the data is in, and it's pretty staggering. We are looking at a 5-fold increase. According to the scientific analyses, the recorded frequency of weather-related disasters has multiplied by 5 in just about the last 50 years. So if your gut intuition was telling you that things are getting way more extreme, the data absolutely validates your suspicions. To figure out exactly why this is happening, here is our roadmap for this explainer. First, the rise of extreme events. Second, the anatomy of a natural disaster. Third, how climate fuels the fire. Fourth, human choices and hidden risks. Fifth, busting some myths with science versus fiction. And finally, engineering a resilient future. Let's dive in. Part 1, the rise of extreme events and mapping the surge in these hazards. Let's start by looking at the financial toll here, because it really paints a picture. Back in the late 20th century, annual economic losses from disasters hovered around $70 to $80 billion. Today, that number has skyrocketed to roughly $200 billion every single year. This steep rise is driven by a collision of two things: physical climate changes and our own expanding infrastructure and population growth in high-risk areas. Moving to Part 2, the anatomy of a natural disaster, focusing on the human element. To truly grasp those rising costs, we kind of have to rethink what a disaster actually is. You see, a natural hazard, like a storm, an earthquake, or a wildfire, isn't inherently a disaster. It only becomes one when it intersects with vulnerable human systems. So the equation is hazard plus vulnerability equals disaster. It's a simple concept, but it's totally profound. Think about it. A massive hurricane over the open ocean is just a hazard. But when that exact same hurricane hits a densely populated, completely unprepared coastline, that human exposure is what turns it into a full-blown disaster. All right, Part 3, how climate fuels the fire. Let's get into the physics of warming. Now, human vulnerability is only half the equation, right? Climate change is acting as this massive amplifier to the hazard itself. And the physics here are pretty straightforward. Burning fossil fuels warms the planet. And because a warmer atmosphere can physically hold a lot more moisture, kind of like a giant sponge, it completely supercharges our hydrological cycle. It turns what used to be normal rainstorms into incredibly heavy flooding and incredibly intense storms. And wow, it's not just the rain, it is the wind too. Some really surprising research shows that warming ocean surface temperatures have actually increased average Atlantic hurricane wind speeds by nearly 18 miles per hour in recent years. That extra heat in the ocean is literally acting like high-octane fuel. It makes these cyclones significantly more powerful and vastly more destructive by the time they make landfall. Now you might be asking yourself, okay, but how do scientists know this for sure? Well, they use a fascinating emerging field called attribution science. This essentially allows researchers to quantify the exact impact of human-induced warming on specific individual extreme events. For example, attribution science has shown that recent exceptional rainfall and flooding events in Brazil were 2 to 3 times more likely to happen strictly because of climate change, compared to if we still had a cooler pre-industrial climate. So climate clearly modifies both the probability and the intensity of these specific events. Which brings us to Part 4, human choices and hidden risks. Basically, how we are building our own vulnerability. When we pivot back to the human side of the equation, we can really see how our own behaviors drastically multiply these risks. Out in nature, landscapes like wetlands and forests naturally act as buffers. They absorb water during storms. But in our built environments, concrete is king. Our heavily paved, impermeable cities leave the water absolutely nowhere to go. This means that the sheer scale of modern flood damage is very often determined by urban design, not just the heavy rain itself. The runoff is just incredibly fast, causing severe urban flooding. So this brings up a crucial yes but moment. Yes, nature is powerful and climate is amplifying hazards, but our choices drastically multiply the danger. Deforestation strips away our natural flood barriers. Unplanned urban expansion puts more and more people directly into floodplains and vulnerable coastal zones. We also have aging infrastructure that is simply failing to account for these new extremes. And we absolutely cannot ignore the socioeconomic reality here. Poorer nations and communities almost always suffer disproportionate harm because they just have limited resources to prepare or build resilient infrastructure in these expanding risk zones. Okay, part 5, busting natural disaster myths. Let's separate the science from the fiction. There is so much information swirling around out there, making it super easy for oversimplified narratives to take hold. Let's clear a few things up. For example, a major myth you might hear is that earthquakes are increasing because of climate change. The science tells us this is completely false. Tectonic events are driven by geological stress deep in the Earth's crust. They are entirely unrelated to the temperature of our atmosphere. The core drivers of seismic activity remain purely geological, not climate-driven. Here's another really common myth. Oh, it's all just natural variability. These disasters have always happened. Well, the science says false. Look, mechanisms like El Niño are very real and they absolutely play significant roles in severe weather. But they cannot explain the steep, long-term trends linked to atmospheric warming that we've mapped out today. Natural variability simply does not account for a 5-fold increase in weather-related disasters over a 50-year period. Finally, part 6, engineering a resilient future. Let's talk about practical solutions for a changing world. We've looked at a lot of hard data, so let's shift gears straight into actionable, science-backed solutions. Because science actually provides a highly practical roadmap to defend our communities. First, it requires climate mitigation, actively reducing greenhouse gas emissions to slow the warming. Second, it demands ecosystem-based adaptation, which means restoring those vital wetlands and natural floodplains so they can absorb water again. Third, we need risk-aware planning to intentionally keep new construction out of known high-risk hazard zones. And finally, infrastructure resilience is absolutely crucial. We need to design buildings and early warning systems that can actually withstand the storms of the future. There's a great quote from the research that I think perfectly sums up this whole explainer. It says, "Understanding these nuances allows us to separate science from myth and focus on what truly mitigates risk." That right there is the core takeaway today. By relying on credible research, we are empowered to build safer, far more resilient human systems. We really don't have to be helpless in the face of these statistics. So I want to leave you with a final, slightly provocative question to chew on. Do you know the true hidden risks built into the landscape of where you live? Next time you're out, take a look at your hometown. Look at your streets, your local natural barriers, or maybe the lack of them, and try to view your local built environment through this entirely new scientific lens. It really changes the way you see the world. Thank you so much for joining me for this explainer. Keep asking questions and stay curious.